Hello, and welcome to this talk about hybrid UI in Tableau Desktop. My name is Sam Thibault. I'm a software engineer on the development team at Tableau, and I'm excited to have the opportunity to tell you a little bit about some work that we've done. In this talk, I'll begin by just introducing you to Tableau in case you're not familiar with Tableau or its products. Then we'll move into what's hybrid UI. I'll show some examples that are in Tableau. WebChannel is the tool that we use for the communication between WebEngine views and native C++ code. We'll talk about why Tableau implemented shared UI and our general approach, and also what are some of the challenges that our team ran into. Tableau helps people see and understand data, and our different products, including Tableau Desktop, provide steps through that process that begins with preparing the data for analysis, exploring the data, producing visualizations, incorporating visualizations into dashboards, sharing those dashboards with other people, and even getting notifications after those are published. We have several products which are part of our platform. In addition to desktop, we have server and online. I'll go into some of those differences between those two in just a moment. Tableau Prep is our tool for cleaning and processing the data before you do the analysis. Tableau Mobile is a way you would consume those vises. And Tableau Public is a free offering for sharing data visualizations. What can Tableau Desktop do? One piece is connecting to data sources, whether that's a local file, say a spreadsheet, or it's a remote database outside your organization. The main UI, which you can see in this screenshot, is largely drag and drop functionality. Those blue and green pills that you see are on what we refer to as the shelves. Those can be manipulated in different ways to create quite a variety of different visualizations. And it has functionality for building the dashboards and then publishing those to our server and online products. Tableau Desktop is available on Windows and Mac, and we also have the server and online products. Online is the hosted version configured by Tableau, or customers can use Tableau Server where they can install it locally on a server or use a option in the cloud, and that's available on Windows and Linux. And as with finding the data either locally or wherever it is, we want to enable customers to do the work where they are. So if they're that single user on desktop or they're a larger organization, whichever environment that they're using, we want to be compatible with all of those approaches. And under all of this is Qt. So the main part of our code is C++, and that has all of our special logic about processing the data, creating these visualizations. We also use WebEngine across all of these platforms. Tableau started using Qt when we ported our desktop product to Mac, and the UI is extensively built with widgets. Let's talk about terminology and go through some examples. So native UI is UI you might build with, say, widgets. Hybrid UI, when we're referring to that, we have a WebEngine view inside our application, and we have web-based UI, HTML, JavaScript running inside of that WebEngine view. Hybrid dialogues are a specific use case of hybrid UI where we are creating a dialog box with the web content inside of that window. Shared UI, when we use that term, that is hybrid UI content used both inside the desktop product and inside our server product. For example, in web authoring, which is a capability, building a visualization is a capability that you can perform in either of those places. And platform abstraction APIs provide the implementations, whether desktop or server, so there's a single interface for that web-based UI. We'll talk more about that in a few slides. Here's a first example of hybrid UI. And some folks might say, well, this is kind of borderline because we're just using a QWebEngineView and going and loading some external content. In the case of the Discover pane, which is what this image has, we have a pane in our start page where content is updated periodically. So in this case, we see like Viz of the Week. Customers can also use web zones inside the dashboards they create. So if, say, a customer has created a visualization, say around inventory, when the user selects a mark in that visualization in a web page as part of the dashboard, they could load from a website that has information about that product. As we start to get a little bit more complex with our uses of WebEngine, here is the next step, which is web data connectors. This is customer-written JavaScript and HTML. It enables Tableau to use that code to go get data that's out on the web, and that gets ingested through a web channel into Tableau. Whereas web data connectors are sort of that one-way flow in, dashboard extensions are a next step where it's two-way communication with Tableau. The dashboard extension can issue commands to Tableau to, say, perform like filtering, and also get results after the visualization's been modified. And there's different APIs for extensions to use, and we have websites around these if you want to go see some of the capabilities of those dashboard extensions. One tool we provide for customers who are building these dashboard extensions is called Tableau UI, which is React components with a look and feel of Tableau. In many cases, they want to build an extension that matches the overall look of Tableau. So that's the purpose of these different components. Finally, shared UI is code written by Tableau, and we're writing hybrid UI for features of the product. In this image, you see a dialog for editing an axis of the visualization. This functionality exists both in our desktop product and in the server and online product with web authoring. So this is the UI that we can write once and use in both places. I mentioned WebChannel. WebChannel has been available since Qt 5.4, and what it's providing is access to a QObject from JavaScript. This is well documented on Qt's website, so I don't want to go deep into the basic details. However, let me just show you one example on the C++ side. This relates to some other details I'm going to share later. So Interop object is the term that Tableau uses to describe these QObjects we're setting up with the web channel. In this case, we have the presentation layer which is our abstraction for sending commands to Tableau and getting notifications back to the WebEngine And the piece that we need to do on the C++ side, once we have that Qobject for our interop object, is register it with the web channel. That's what you can see in this snippet here. In Tableau, we have several different interop objects that we're registering, so we're just going through and registering each of those objects with the web channel. So let's talk about the larger picture of implementing shared UI. Why did Tableau pursue shared UI? One motivation for this was just to reduce the amount of maintenance we were doing on our code base. It's been said inside our development team that we liked Tableau so much we wrote it twice, and that's our creation of the native desktop application, and then online and server, which has very different code. Our feature teams have to work on implementing features in both of these, and we wanted to make it easier for them. And this hybrid UI approach was one way to do that. It also fit with some of the shifts we were seeing just in terms of expertise on the expertise towards TypeScript and React. This wasn't a do everything at once kind of approach. It's tiny steps of individual dialogues. So in places where we do have functionality that's the same for desktop and server and online, the example I showed earlier with edit access is one of those. That was a place where we could take advantage of shared UI. We still care about the desktop application having the feel of a native application. And so part of that's just ensuring that the main visualization rendering performance isn't impacted. We want to have these dialogues which are launching have a quick load time. So we do some things to warm up a WebEngine instance before we launch the dialog. We also make our dialog boxes so they can be dragged outside of the native application window. They have their own window with the WebEngine inside of it. And part of our APIs is for using things like context menus and combo boxes where the UI is going to drop outside of that dialog box. We wanted that to have the native types of behavior rather than be limited by the bounds of the web canvas. Platform abstractions APIs, I showed an interop object for the presentation layer before. So executing commands and getting notifications is one example. Also, the functionality for widgets. There's other pieces that we have. And these are providing a uniform interface for the hybrid UI content. Once we get past these abstractions, we get to specific implementations, whether that's for desktop or for our server and online products. When the dialog is launched, we get the appropriate implementation, and on desktop, that's use of the web channel. So here we see, okay, desktop implementation goes through the web channel to the desktop interop objects. If we look at the larger picture, we can see that we have still QWidgets and a lot of our existing product logic, which uses those calls to commands and parameters into the C++ code. Then we also have the new hybrid UI, which is also executing commands. Because those could be doing the same types of things, say filtering, those commands around, say, filtering has its own feature-specific API, and we need to keep that in sync between the C++ code and our web code. And we have a system of generated code that helps with that. When a build runs, it does validation to make sure those two signatures match and notifies the developer if they've gotten out of sync for some reason. This image is just to show an example of debugging a hybrid dialog. In this case, we again see the edit access dialog. We have dev Chrome tools or Chrome dev tools running, and you can do things to debug it here. You could look at the JavaScript and set breakpoints. And this is something that customers who are building dashboard extensions, that they could follow the same approach to help get their functionality working and make changes to their extension UI. All right, let's wrap up by talking about some of the challenges that Tableau ran into when we were implementing this. I've put a star on this slide because these were kind of the big ones around WebEngine. One challenge is getting the latest version of Chromium in QWebEngine. That's related to when release cycles are happening. We also care about being able to deliver Tableau for all the hardware our customers might want to run Tableau Desktop on. Recently, Apple Silicon has been released, and being able to build Tableau to run on Rosetta 2 is really essential. We also had challenges with rendering. So our native application already was using hardware acceleration, so Angle on Windows, to render things like the visualizations. However, when we have instances of WebEngine in the product for, say, a dashboard extension, WebGL is not compatible with Angle because of thread safety issues. So that's a limitation right now that our customers have, and that's something we're still want to solve for customers so they can use WebGL inside of their extensions. Threading was a place where we needed to do a lot of work. Originally, Tableau Desktop was written with a very synchronous model. That wasn't so bad with WebKit because WebKit, again, that's been deprecated, but WebKit was also synchronous calls, whereas WebEngine is asynchronous. Therefore, we needed to make some changes to handle those asynchronous calls correctly, especially because we have commands coming from maybe multiple extensions and also our native UI. One thing we needed to be careful here was to make sure we were catching all the exceptions that could come through a slot, because if we missed anything, that would break the connection with the web channel. Web security, of course, we needed to ensure we were handling issues here. For our larger customers that are using smart cards for two-factor authentication, being able to communicate with that from WebEngine was necessary. Also, in terms of packaging up our hybrid UI with the desktop product, we put JavaScript and HTML into QRC files, and we needed to solve the problem of how do we get WebEngine to be able to access that content. And lastly, extensibility. Our customers did unexpected things with our extensions in terms of how did they set it up to call commands, ensuring safety between the different extensions, and making sure that performance was still good when they had lots of WebEngine instance running. Those were issues that we needed to address. All right, so we're at the end of this 20-minute talk. We went through some information about Tableau, some hybrid UI terminology, and examples of that inside Tableau, and looked at WebChannel, how we approached implementing shared UI, and finally, some of the challenges that Tableau encountered as we were building this. There are resources that are out there if you want to learn about WebChannel, if you want to learn more about, say, dashboard extensions as an example of something that Tableau has built. And we're going to follow this with Q&A, so I will answer any questions there. Thank you very much.